Good morning, ladies and gentlemen. Welcome to another exciting episode of Dave Does Math from Home. We got a good one for you today. This is our opening lesson for Calc 2. And we are opening Calc 2 with a section that does not exist. There is no section 5.0. 5.0 is what I'm calling this because this section of homework problems is a collection of review problems from the end of Calc 1. Calc 2 picks up pretty much right where Calc 1 left off. We're just going to go straight into it. And so we're going to start by doing a quick review of exactly where we left off so we know exactly how the new ideas carry straight through. So the first big idea we need to talk about is a Riemann sum. Riemann sum is a way to approximate the area under a curve using rectangles. So if you have a function like 1 over x, and you want to find the area underneath this function between x equals 1 and x equals 5. One of the ways you could do this to approximate this area would be to split this up into a number of rectangles. So 2, 3, 4. Okay. Let me distribute these a little better. 2, 2, 2. Okay, there we go. So 2, 3, and 4. We're going to split this region up into 4 rectangles. And then for each rectangle, you can pretty clearly see that we have a little rectangular base here and some area that goes up, a little rectangular base here and some area that goes up, rectangular base and area upwards, rectangular base and area upwards. 3 sides of each of these shapes is a nice, reasonable rectangle with straight edges and right corners. The problem is going to start when we get to the top of this, because the third edge of each of these shapes is not a straight or flat line. It's this curve. So we need to choose whether we're going to use the left endpoint for this rectangle and have the area go all the way up to here, and then we get a little bit of an overestimate, or we could choose to use the right endpoint of each of these rectangles and have it end here, and only look at this area, and then we have a bit of an underestimate. Whichever you choose, you're going to be off in some direction or another, so it doesn't super matter. For this one, let's do left endpoints and finish it that way. So we'll take the overestimate of this. So if we're using left endpoints, the x values we're using are 1, 2, 3, and 4. 5 is the rightmost edge of this area, but we're not going to use it because for this rectangle between 4 and 5, we're using 4 as the grid point. We're not using 5 for anything. If we were using right endpoints, then we would use the grid point 5. The height of these rectangles is secretly just f of x. Or let me call these, to match the way the book does this, I'll call this x naught are the grid points, or x sub I guess are the grid points, x sub n maybe. And this is f of x sub I. So f of 1 should be 1, f of 2 should be 1/2, or 0.5. f of 3 should be 0.33, and f of 4 should be 0.25. These are the heights of each of these rectangles. The width of each of these rectangles is just 1. It's the distance between your grid points. And so the areas, the book calls this delta x, not width. The areas you get here are 1, 0.5, 0.33, and 0.25. If you add them together, you should get the total, an approximation for the total area between this curve, or under this curve between these points. And we think you get 1.75, 2.08-ish. So that's an overestimate. It's probably a little lower than that. But that's a Riemann sum. We are reviewing Riemann sums because these form the basis for our definite integrals. And Calc 2 has a lot to do with definite integrals. We're going to be talking about them pretty much non-stop for most of the course. And using Riemann sums as the basis for that, it's going to work a little differently than how we used. In Calc 1, we used limits as sort of the foundation for our derivatives. And that's a great way to introduce derivatives, but once we had done that, we kind of never went back to limits. Limits sort of disappeared after those first couple weeks of Calc 1. Riemann sums are different. Most of the stuff we're going to do with definite integrals in this course comes back to the idea of slicing little pieces of a function up to get an approximation. So this idea is going to come back a couple times. We'll review it more when that happens. But for now, we're just going to review it like this, do some Riemann sums in the homework, and there's that. The other big idea we need to review for this particular video is the fundamental theorem of calculus, which is a really big fancy word for something that you probably already know. This symbol without numbers on the top and bottom, this means antiderivative. And the antiderivative of this is x cubed 1/3 x cubed plus c. This symbol with numbers on the top and bottom, this means definite integral. Sometimes this is called an indefinite integral. Definite means being like a defined region. So definite comes from defined. This is on a defined region. This is indefined, so it is an indefinite integral. They're both integrals. The definite integral means the area under x squared between 1 and 10. The fundamental theorem of calculus is what connects this together. The fundamental theorem of calculus is the thing that says if we want the area under this curve between these points, we can get that area by looking at the antiderivative and evaluating it at these two numbers and then subtracting them. That's what the fundamental theorem says. The fundamental theorem is what connects antiderivatives to areas which otherwise would not be connected. So that's kind of a big deal. That's important. We can find this just using this antiderivative. This is 1,000 over 3 minus 1 over 3. That's 999 over 3. So 333 is the area beneath x squared from 1 to 10. And it's pretty outstanding that we can do that so effortlessly. We can find this area. This is not a standard area. This is what the fundamental theorem of calculus gives us. So the homework questions you're going to see in this section, they will ask you to do some Riemann sum review. So make those tables, make the rectangles, add things together. And they'll ask you to do some fundamental theorem of calculus review, which is a good way to review not only antiderivatives, but also evaluating those antiderivatives to find a area under the curve. That's about it for this review video. Hopefully this all comes back pretty quick and the homework presents no challenges. But if it does, you know where to find me.